we gotta go. If you finish the work, this is for people that are finished. Okay, finish the question.
Volcanic activity potentially threatens millions of people worldwide. But equally threatening is another common geologic phenomenon: earthquakes.
He's working until I say turn the one.
Geologists have a general understanding of how earthquakes occur, and the areas most prone to earthquakes have also been identified. But much remains to be learned about these events. While scientists have successfully identified some signs of impending earthquakes, these precursors give little clue as to exactly when an earthquake will strike or how large it will be. Along one pastoral stretch of the San Andreas Fault near Hartfield, California, scientists hope to learn more about earthquake precursors and what actually happens during an earthquake itself. Geophysicists are using a sophisticated array of devices to closely monitor movement along the fault. The objective is to spot any changes that might signal an impending quake.
The Hartfield experiment has 3 goals. One goal is to try to issue a short-term prediction of the Hartfield earthquake. And if successful, it'll be the first time we've ever done something like that in this country. The second goal is to record the details of the earthquake generation process in as much detail as possible. And the third goal is to take advantage of the fact that we'll have a moderate earthquake to record some of the effects of the earthquake, such as the amount of shaking that occur at different distances from the fault.
While earthquake prediction is a significant goal for geologists, most stress that earthquake preparation is even more important.
First of all, we must try to shore up existing structures and make them more earthquake resistant. There is no such thing as an earthquake-proof structure, not at least an economically good one. But we can make things earthquake resistant so that loss of life is minimal, maybe zero loss of life. That can be done now and should be. It's very expensive, but we must re-strengthen old buildings, old structures. Furthermore, we have laws on the books that prevent building new structures in earthquake-prone areas where the dangers are excessive. Those laws should be maintained and perhaps even strengthened. We have also building codes that require modern buildings to be built sufficient to withstand intense ground shaking. continued research into building structures of all sorts and their resistivity to earthquakes must go forward. That's something we can do now. We don't need to know when the next earthquake is coming to know it's important to build buildings that stay up and don't lose windows and facing material in the event of an earthquake.
Even more destructive than volcanoes and earthquakes are mud flows, landslides, and other related earth movements. Every year, they exact a staggering toll on populated areas. In some places, people have attempted to live with land movements, although not always very successfully. When new construction is planned for areas with slopes, geologists are often called upon to evaluate potential landslide risk.
Let's see where we are. Get your compass. Got the limits. Slide here.
First, the proposed building site is mapped.
Cuts down.
Next, drilling is done to give the geologists a direct view of the subsurface structure at the site. Along with soil samples obtained during the drilling process, this provides much needed data about the history of landslide activity in the area.
As we drill the hole in that area, we will be sampling the material to determine how strong it is. We will also be describing it in terms of its soil characteristics such as grain size, moisture, color, a variety of types of characteristics which will be useful to the engineers in the office when they determine whether or not the material will be suitable to stand in a slope or to be reused as fill somewhere else on the site. Once we've worked with our engineers in the office and determined whether or not the slopes proposed will be stable, what type of removals are necessary, we'll prepare a report with all this information that we can then share with the client.
After evaluating the stability of a site, geologists can make recommendations about whether a building project should be undertaken. Ultimately, this can help minimize the risk of death and destruction due to landslide activity.
The human population of this planet is now close to 6 billion, and it's increasing exponentially. Many of the world's population centers are located in areas threatened by natural geologic hazards, such as earthquakes, volcanic eruptions, and landslides. Geologists are working to understand the exact nature of hazardous geologic processes like these, and then applying this knowledge to reduce the toll on human life. The teeming industrialized societies that have resulted from this population explosion have also spawned environmental problems, which are only now being recognized. Geologists are actively involved in the battle to overcome a broad range of these problems. And as the world's population continues to grow, the environmental challenge looms ever larger, and the stakes grow even higher.
Today's Earth scientist is expected to play a dual role, helping to locate valuable natural resources, while at the same time protecting the environment, which provides those resources in the first place.
Geologists and earth scientists in general are the scientists who are capable of dealing with the problems of resource extraction and environmental protection. We therefore have a dual obligation to society to maintain our material base by providing the resources to the populace and by maintaining some control over environmental degradation. We can't have it both ways. Every time we modify the environment, to some extent, it is degraded. We can't make it better, no matter what some of the ads may say. So we've got to be certain that we use our resources as wisely as possible. Good scientists know the nature of the resources, where they're located, what their occurrence is, how we can extract them efficiently. That must be an important goal for the future. Make certain that we use our resources as efficiently and effectively as possible, with as little waste as possible, for future generations.
Whether Whether the resource in question is fossil fuel, soil, or groundwater, geologists are charged with a unique responsibility: providing the public with a fundamental awareness of how planet Earth functions.
Perhaps more than any other science, geology has influenced the evolution of civilization and the history of nations. Natural geologic hazards have devastated cities and contributed to the fall of governments. The geographic distribution of fossil fuels, precious metals and gems, and industrial minerals have created empires and caused wars. It has allowed the citizens of some nations to enjoy boundless prosperity, while those living in less fortunate regions struggle to eke out a marginal existence. But geology has given us more than oil and metals and predictions of natural disasters. The science of geology was founded not for economic benefit, but from human curiosity about the Earth, and it's provided us with a way to understand this planet we call home. Geologists rarely conduct experiments. It's not possible to carefully control the geologic conditions in this global laboratory. Instead, working from the shreds of evidence that have escaped erosion and destruction by geologic processes, geologists have pieced together the details of Earth function and history. The image of Earth from space is a kind of visual metaphor for the science of geology. From space, we can perceive only the dimmest of clues about the planet lying beneath the swirling clouds and deep blue oceans. To unlock the mysteries of our complex and beautiful planet, and to understand its significance to our own lives, we must carefully examine the processes and products of geologic activity. And during the course of Earth Revealed, that's exactly what we propose to do.
Okay, keep working for about 2 or 3 more minutes, and then you turn off.